All right, we've got here some properties of the natural logarithm. Now, I did another video just called Properties of Logarithms, which all the stuff over here on blue, those are things that I covered in that other video, just logarithms in general. So if you haven't watched that video yet, you should, because the properties of natural logarithms are exactly the same as the ones we talked about previously on that other video, just properties of regular everyday logarithms. It's just, since the natural log has that different notation, the ln, sometimes people get confused about what that means and do these other properties still apply? But the natural logarithm is a logarithm just like any other, right? Just like if I have a log base 5, well, a natural logarithm is just a log base e, right? It's that special number e, 2.718, and so on. Right? But the rules that we use for logarithms also apply to natural logarithms. It doesn't change, right? So I just put up here, hopefully you watched that other video that I did on properties of logarithms, right? Log base a of 1 equals 0, because if you do it to exponential form, well, I'm not going to go through all this stuff again. If you haven't watched that video, watch that other video where I explain why each of these properties works the way it does, and it'll help make sense of all the stuff we're talking about here, right? So the first property, the natural log of 1 always equals 0. Right? If I have a base e and I have to raise it to some power to make it equal 1, well, e raised to the 0 power equals 1. Anything raised to the 0 power equals 1, just like that property over there, right? Ln of e equals 1, right? So these two up here are ones that you'll use every once in a while. I'm not going to say like they never come up, because they do come up occasionally, where if you remember these properties, it'll help you in simplifying pretty quickly, especially the second one, ln of e equals 1, right? That comes up, fairly often in the problems that you do working through algebra, precalculus, calculus. Every once in a while you'll see problems where you have ln of e, and a lot of students I've worked with before freeze at that point. They're like, ln of e, what does that equal to? Well, that equals 1, and if you remember that, it's really easy to simplify. Just that whole thing just becomes a 1, right? And the reason that works is because, remember, the natural log is a logarithm with base e. So if I do e, I have to raise it to some power to make it equal e. Well, it's e raised to the first power to equal e, right? So the ln of e is always going to equal 1, right? Just like log base 5 of 5 is always going to equal 1, right? If the base of the logarithm matches the number that's inside there, it's like they just cancel each other out and it just equals 1. Right? Same idea for number 3 here. The natural log of e to the x power equals x. Right? Just like over here, log base a of a to the x power equals x. If the base of your logarithm, which remember for the ln, for the natural logarithm, it's base e, if that base of the logarithm matches the base of the exponent, they cancel each other out. Right? The ln cancels out the e. Right? Just like over here, the log base a cancels out that a raised to a power. Right? Even here, the ln and the e cancel out, and we're left with a 1 behind. It doesn't just cancel out and leave nothing, not just a 0 behind. It still leaves a 1. In this case, if that e is being raised to a power, that power is what's left behind when the ln and the e cancel. Right? And if I have e to the ln of x, that also equals x. Once again, the e and the natural log cancel each other out because they are inverse functions of each other. Right, so all that's left behind there is the x. Just like over here, a to the log base a of x, as long as the base of the exponent matches the base of the logarithm, they're going to cancel each other out. So the biggest hang-up people have on remembering these rules are remembering that the natural log is base e. Right? If the ln is base e, well then anytime the ln and the e get together, they're going to cancel each other out, right? Whether it's ln of e to a power or e raised to a power that involves the ln, either way they're canceling each other, right? So these two here, properties 3 and 4, are definitely the most important ones of this list to know, because when we're solving equations that involve natural logs, or if we're solving equations that involve e raised to a power, we're using the ln to cancel out the e, or here we're using the e to cancel out the natural log. Right? So since they're inverses, we have to use the one to cancel out the other. So these cancellation properties we have here are very useful, and they're used a lot when you're dealing with problems that involve logarithms and exponential functions. All right? So those are the properties of natural logarithms. Again, they're the exact same thing as the properties of regular logarithms that we talked about previously. The natural logarithm is just like any other logarithm. It's just since it has that base e, which is used a lot in modeling real life situations, it gets its own special designation. But the properties as far as working with logarithms, doesn't matter what the base is, whether it's base e or base 10 or base 5 or base 17.2. The rules for working with logarithms are the same for all logarithms. Okay, so I'm going to pause this recording here and erase this and put up just a couple examples of working with natural logs. All right, so we got a few examples here working with natural logarithms. So the first one, we have natural log of e to the 8th power. Right, so there's a couple ways we could approach this. We could approach it the dumb way, which would be, I don't know anything about logarithms, but I know there's an ln button on my calculator, so let me use that. All right, so I'll hit the ln, y'all can't see that. So it's the ln button, and then I do e to the 8th power, and let me show you after I finish typing it in. So, all right, if I type into my calculator ln of e to the 8th power and hit enter, I get 8. All right, so ln of e to the 8th equals 8. Was there an easier way to do that? There was, right? Remember, logarithms and exponentials are inverses of each other if they have the same base, right? My exponential expression here, e to the 8th power, that has a base of e. My natural logarithm, ln, also has a base of e. And since those bases match, they just cancel out, and all that's left is that exponent, which is 8. All right, so that's that cancellation property of logarithms and exponentials I was talking about 1 or 2 minutes ago. That's how it works in action, right? So anytime you have ln of e raised to a power, the ln and that e are just going to cancel out every time. All right, ln of e to the 1 over e squared. All right, again, I can do this in my calculator. ln of 1 divided by, and then e to the 2nd power, and close all these parentheses. Right, so if I do I do ln of 1 divided by e to the 2nd power, I get -2. Right, so how could I figure that out without using the calculator? Well, here's how, right? So I cannot just use like what I did up here where the ln and the e canceled out. I can't do that here because it's not just ln of e to a power, it's 1 over e to a power, right? And the cancellation properties don't say anything about being able to do that when the e is in the denominator of a fraction. But if I know my rules of exponents, I can change this so it looks more like this one up here. Right, I can rewrite this as ln of, and instead of 1 over e squared, I can write that as e to the -2 power. Right, remember, negative exponents means taking the reciprocal of the base. Right, so e to the -2 is 1 over e to the +2. Right, so it's an important little algebraic trick to know. If I need to apply rules, but I can't do it because something is in the denominator, I just bring it out of the denominator and I make the exponent negative. And now the ln and the e will cancel out, and all that's left is that -2. All right, so using that cancellation property of logarithms and exponentials, sometimes though you have to do a little bit of algebraic manipulations to get it just in that proper form where you can actually cancel them out. Right, it has to be ln of e to something. It can't be ln of 1 over e to something, then they're not going to cancel out. All right, the last one up here, ln of 5. Well, for this one, I don't have any choice. I got to use the calculator, right? Because I cannot write 5 as e raised to a power, right? Like here was e to the 8th power. Here I could rewrite this as e to the -2 power. I'm not going to be able to rewrite 5 as e raised to a power so that the ln and the e would cancel out. So what I do then is just go to my calculator and I type in ln of 5, hit enter, and I got 1.609437912. So ln of 5 is approximately 1.609, let's say. Right, so what does that mean that ln of 5 equals 1.609? Well, remember, write it in terms of the exponential, right? ln, the natural logarithm, has base e. Right, so there's a little e here. If I do e raised to this power, so e to the 1.609 power, that's going to approximately equal this number here, 5. Right, so remember, logarithms are just different ways of writing that exponential relationship. Right, I have a base of e, I need to raise it to some power to make it equal 5. What power do I have to raise it to? Turns out that it's 1.609 approximately, right? It wasn't exactly that I had to round that decimal off, but that's what we get from there. All right, so that's doing a little bit of work with logarithms, natural logarithms. Again, I've done a whole bunch of videos on logarithms, and I'll be doing more as well. So make sure you check out all those videos about the properties of logarithms, definitions of logarithms, and then I'll also be doing some where we're solving exponential and logarithmic equations, which is really where a lot of the stuff I've been talking about in these past couple videos that I did really becomes useful, is when you have to use those to actually solve equations, which is a lot of what algebra is about, and precalculus and calculus as well. So make sure you check out all those other videos.